Hello guys, my name is Kamil. I'm a CCNA and CCNP in routing and switching. I have also, learned a little bit for RHCSA and RHCE with Red Hat. I have not taken the exams because of the price, but I do have the knowledge. In terms of the Python, I've worked a bit with MOOC courses online, like Udemy, like from platforms like Udemy, Coursera, EDX. One of them was Computer Science 50, which I deem a really nice course that teaches you how to think in a programmatical manner, which is super useful. And apart from that, I started creating some projects, and I've created two of them really. One is a subnetting calculator, and this one now is an STP trainer, which is much more involved, yeah, I would put it this way, and I came up with it on my own, just using some documentation, some references online whenever I had to look at them. But anyway, I'm not going to show you the source code in this video. If you decide that you enjoy this video enough, please just drop me a line, and what I'm gonna do is I'm going to create more of the videos, and I am going to include information about the source code in them as well. At the moment, the main goal is just to present to you how the STP Trainer works in its graphical excuse me, in its graphical representation. So let's have a look at it. It's quite simple, but super useful, I believe. Anyway, so let's run it. There we go. The first pop-up screen is the main menu, you could say. It's saying a lot about it though, because all it includes is just information about the program, right? It tells you that there are 29 different possible topologies that you can work with. There are 3, 4, 5 or 6 switches at the max, and you are allowed to change the links between them if you'd like to, because after all it's all just JSON files, so you can manipulate them. But I would advise you not to go above 6 switches at all, because of the way I've designed the program. And the main goal of the program is for you to practice STP skills by providing proper markings on every and each single port in the topology. So there could be a root port, it could be designated port, or a blocking port. And at the moment, that's all I would like to say about this screen. If you would like to proceed and get your first topology to look at, you press get domain. And the other thing that is important here is anytime you want to get a new domain, you just come back to this screen and press get domain. That will randomly select you one of these topologies. I mean one out of those 29 that I've created for you, yeah? Although you can create more if you really want to, alright? Well, let's press get domain. And there we go, we have 4 switches this time. Now the first step I would like to do is to figure out which of those switches is going to be a root bridge. Let's have a look. So switch 1, no, and that can be done by just clicking on them, as it says here. Click on any switch to get the answers. And what could be the answers? The answers could be whatever is marked in terms of the radio buttons. So it could be a bridge ID, a switch row. It could be ports that are coming out of this switch, and could be the lowest cost to the root bridge as well, which is pre-calculated for you. Yeah, this is a bit of a cheating if you go too far with it, but at the very start I think it could be a useful tool for you to figure out why the answers comes out as they do. But anyway, let's have a look at the bridge IDs. So the way I created it is it starts with the bridge priority as it normally does. However, I do not include a full 6 bytes long MAC address, because I believe that if you can just follow numbers from left to right and see which one is the lowest, then you got it, then you'll be able to identify which switch is the root bridge, because it's always going to be the switch with the lowest bridge priority, alright, or bridge ID, however you like to call it. So let's have a look which one is the actual root bridge now. So this one is lower than this one. Switch 3 is lower than you know, it's actually, no, it's the worst out of those three. Switch 4 is the winner. Hooray, we have a winner. So that's gonna be a root bridge. Shall we verify it? Sure, why not? Let's look at his switch role. Yes, he is a root. He is a root, so that's okay. What about the port? I just show you how it works. So let's say port, and let's say on switch 1 we do have two ports, yeah, that's true. One of them has got cost of 4 and leads to switch 3, which is this one, number 1, and that's very true. And also another thing to come up with now to tell you is the legend on the left. It's quite simple. It just explains you the cost of the links in terms of the colors. So if it's green, it's 4 for gigabit link. If it's yellow, it's 19 for fast Ethernet links. And if it's a 16 megabits link, then you have 62. I know it's a bit limited. There are no more, costs, which could be disappointing for you, but it has been done again for simplicity to get you to practice your STPs straight away and in an easy manner, rather than give you massive values like in MSD, for instance, like 2 millions or 200,000 or 2,000. I believe this is like an easier way. It's commonly used while practicing anyway. So I stayed with that, and hopefully you appreciate that. Anyway, there's another thing here that's worth looking at, and that's lowest. Let's look at the root bridge lowest. Lowest is gonna be 0. Yes, true, because there isn't any cost, because that's the root bridge. However, for 1 it seems that the lowest cost is 23, and it goes to switch 2. Let's verify it quickly. So, if you go, I would say no, I don't want that one, I would like to go this way. But let's reason with it. So switch 1 going to switch 3 is 4, which is cool. It's better than this, because that's 19, that's ugly, yeah? We prefer this path, yeah, surely. However, look now, we need to go from switch 3 to switch 4, and this one is really bad, it's 62. So that would give you like 66 total cost, that's super big. But if we go for switch 2, yes, we start with 19, but then all we do, we add another 4 on top of it, and that's only gonna give us 23, which is much better than this cost. And this is why this is the lowest, path cost. And this type of ports we're gonna call root ports. So the ports with the lowest cost towards the roof, towards the root bridge. So that's cool. Let's have a look at how this program should actually work now. All right. So let's input some ports. So root ports. So we've already told that number 3 is a root port, so we can do that one now. That I like to start with root ports. On switch 2 it's gonna be 5 because it's only cost of 4, and that's okay, and it's the only one really leading here. Otherwise you can go all the way around and accumulate a super massive cost, which we don't want to do. Switch 3, even though it seems like it's super quick to go through here, it is not, because this way the cost is much lower. It's like 62 versus 27. I take 27 every day. So let's do number 2 as a root. Now what we also know is that all of the root bridge ports are gonna be designated, because designated also means forwarding, and they have to be forwarding to share something called PDU, which is Bridge Packet Data Unit, which contains a lot of information like cost, and that all of these switches will share with each other by sending it via designated port. And that's especially true for 802.1d, which is a pretty old protocol, right? But yeah, this is the main idea about how it works, and that's cool. Let's have a look at designated ports then. So we have 6 and 8. We need to have 4 designated because it has to be forwarding, and 3 is a root, so 4 is designated. In here 1 is designated because 2 is a root and it needs to be forwarding, so let's do that. And the blocking port looks like the only blocking port we have is number 7, and that will complete our tree. Let's see anyway. Yes, it is, because this is a root bridge, so it's got to have designated port. This has to be blocking because otherwise the broadcast will be happening like this or like this. If it's blocking, even though the broadcast might get to that port through this side, the switch will just drop it. It won't care about it. So let's see. And this is a correct way of doing it. So we got a tick, a happy tick. Let's have a look at this again. Let's mess something up. So 7, 1, and that's gonna be 7 here. See, and now it tells you that, oh no, please try again, you made a mistake. And there you go, the X that tells you this is a mistake. That's the first indication. You have this message, please try again, and here as well if you didn't realize yet. And you have some help here, as you know, as much as you have it here as well. So port 1 is not blocking. That's true. Port 7 is not designated. And this is also very true. So why don't we change it back to what it was? And this way it should work now, yeah? Oh, actually let's leave 9. There's no port 9. Let's see what's gonna happen if I'll do it like that. Uh-oh, some of given port numbers are not inside of range, and you get it here as well. And that's very true. There's no port 9 on the whole topology, so yeah, that would be why this answer came up. What about if I don't give something here at all? Oops, please provide port numbers using a comma as a separator. Yeah, that's an important info. And you need to provide commas between your ports unless you've only got one number in there. Like in this case scenario, we only needed to add one more. Let's see what one we're missing now. 1, 2, 3, 4, 5, 6. We need missing 7. So I'll add 7, and we're back in the game, and we got a nice tick. So let's try another topology quickly. This time I'm gonna go over it quicker. So let's see. Let's find all of the root ports. Right, let's find the root bridge first. So yeah, it's gonna be switch free this time. That's okay. Now let's find the root ports to that switch. I'll start with number 1. It looks like the closest is 1 because it's 19 versus 23, as I can tell. Switch to the lowest is also 23. It goes over 7 this way rather than here. So I'll put 7 down here. Then you got switch 4. It's definitely 10. It's only 4. So that's super nice. I'll put it down here. Then, oops, sorry, I'm not very good at writing and typing. For switch 5, it's got to be 14. So I'll do 14 as a root port. And for switch 6 it will be 18, even though this seems shorter, but it's not, so I'll give 18 because of the cost. It's much better. In terms of designated ports, I always start with our given, which is a root bridge. So 2, 6, 9 and 11. They don't have to come in any particular order anyway, the way it's been programmed, but I'll do it this time like that. Now let's find other designated ports here. So we know that this was a root that's designated. We've already got that covered. Now we have this link here, so let's have a look at 3 and 4. 3 is gonna be blocking because this is a worse cost than from switch 4 to switch 3. So 4 will actually become our designated port, and 3 will become a first blocking port. Next links, 5 and 6. 6 is a root. 6 is a designated port on switch 3, however 5 will be blocking on switch 2 because we need to block those broadcasts, remember? So let's block it here, and the cost is awful here anyway. 7 is a root, we know that. Because it's a root, number 8 needs to be designated, so we know that straight away. We can change that. Next, this is all done. I think this part is done now, so let's go below. So switch 5, or even look at 11 and 12. We know that 12 will be blocking here. We can tell by just looking at it. We know that's a root bridge and that's a super low cost. It's exactly in here actually. However, in here you look at the costs. So switch 6, the lowest cost, is going through. It's got to even go through switch 4. See? And switch 4 is only one hop away. So this will be designated because that's definitely it's got much better cost than this switch has. So I'll put it 15 here, and the blocking will be 16 this time. In terms of 17 and 18, 17 needs to be forwarding for 18 to be able to be root port and go through here. So 17 will become a designated port, and 18 we've already got marked up, so that's okay. and for the same reasons 13 will be designated port here for switch files root. So let's do that. And the other thing, I think we got, have we got anything else left now? Let's have a look. 1, 2, 3, where's 4 here? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So it looks like it's all marked up. Whether it's been done right, we'll have a look. No! I've missed a separator somewhere. Let's have a look what I've done. So everything here seems to be looking good. So I don't actually, look, I've put one too many. And yeah, you got it now. So yeah, the program is actually helping you out a little bit. Yeah, it will tell you if you forgot something or not. This was a silly mistake, this situation. Well, hooray, I'm not perfect anyway, so yeah, that's fine. However, this is how it works. And I mean, I hope it's gonna be helpful for you guys. And as I said before, this is only a graphical user interface of it. I am not showing you a CLI version of it now. If you would be interested, just let me know, and I could always create more videos on it and explain how it works a little bit more behind the scenes, because obviously there's a source code for it. And by the way, on top of that, if you just want to look at it, it's gonna be on my GitHub account, and what I will do is I'm gonna attach a link to it underneath the video, so you can feel free to have a look at it. And it contains both, or actually three things. It contains my subnetting calculator, STP Trainer CLI, and STP Trainer in GUI version. So you can have a look at all of these if you really want to. The only thing that to wrap it up is how to shut the thing down. So the way I did do it is you need to go back, and to shut it down you just press that red X at the top right corner. Alright, if you do this, that will shut everything down. And right now I just want to thank you for bearing with me all this time, and I hope you enjoyed it, and I hope this will be useful for your studies for CCNA, CCNP, or just learning STP protocol in general. Thank you. Bye guys.